Welcome to lesson DN2 for dynamics. Force equals mass times acceleration. We're going to start by just taking a look at an object, and we're going to apply a force to that object one at a time. A box sits on a table. The force of gravity pushes down on the box, but the box does not fall through the table because the table pushes back. The force of gravity is equal and opposite to the normal force. The object does not move because the net force is equal to 0. If we were to apply a force that would drag the box to the left, friction would work against the direction the box was moving. And since we're pulling the box slightly off the ground, the table does not have to push up quite so hard on the box. The force we are applying can be separated into its horizontal and its vertical components. The net force is the addition of all these forces. Since the box is not moving up or down, the net force acting vertically has to add up to 0. Force applied horizontally is longer than the force of friction. The difference in their magnitudes will equal the net force. Now that we know the net force acting on the object, we can use the formula F net equals mass times acceleration. We can determine acceleration using this formula when we know how much the box weighs. All questions dealing with force and momentum need a diagram of reasonable size that shows things like direction, mass, and the forces acting on the objects. We want to make sure we draw a diagram for every question that we do because every question is unique and there will be different forces acting on the object. Example 1. Calculate the acceleration of a 280 kilogram missile at its highest point while traveling east. At this point, wind resistance amounts to 1,840 newtons, the engines produce 7,248 newtons of force, and the up force is equal to that of gravity, which is pushing the rocket downward. So we have a rocket that is traveling to the east. The wind resistance is 1,840 newtons, so that is going to be working against the direction of the rocket. So Fk is equal to 1,840 newtons west. The rocket's engines are pushing with 7,248 newtons of force. So the force applied is 7,248 newtons east. We're told that the up force is equal to the force of gravity, and since they are equal and opposite in direction, they will cancel out. So that means our net force is equal to the force applied plus the force of the wind resistance. So F net equals 7,248 newtons east plus 1,840 newtons west. East is going to win, so we will switch both directions to east by changing the west direction to a negative. We will merge the two numbers, and our net force is equal to 5,408 newtons east. I'm looking for acceleration. I now know F net. I also was given mass in the question, so I'm going to use F net equals mass times acceleration. To solve for acceleration, I will divide both sides by m. The m's on the right-hand side factor out. Acceleration is equal to F net divided by m. I will substitute my numbers in. I get an answer of 19.31 meters per second squared. So my final answer is 19.3 meters per second squared east. Example 2. I've got a calf and he's being pulled east. The rope used is 32 degrees from the horizontal and he's being pulled with a force of 780 newtons. So there's a rope around this calf. He's getting pulled east with a force of 780 newtons. We said that the rope is 32 degrees from the horizontal. So that means I have a horizontal component So if I've been given 32 degrees, 780 would be my hypotenuse. Horizontal side would be my adjacent side, so I'd use cosine to find the force applied horizontally. That means there's also a vertical component. That would be force applied in the up direction. And from the 32 degrees, that would be the opposite side. So to solve for force applied in the upward direction, I'd use sine. Again, 780 is my hypotenuse. My angle is 32 degrees. My force applied in the up direction is then 413.34 newtons up. I'm told the frictional force comes to 570 newtons. Since the calf is going east, friction always works in the opposite direction of the object, so that means the frictional force Fk is going to be 570 newtons west. It says calculate the normal force. So we know the normal force always pushes up from the bottom. The only force that we're missing right now is gravity, because we know gravity must be pushing down on the object, so Fg is pushing down. Now I don't have a value for Fg, but I can find that because the force of gravity equals mass times acceleration. And when we're talking about gravity, that's the acceleration due to gravity. I know the mass of the calf, and acceleration due to gravity is always 9.80 meters per second squared. So when I run that through my calculator, that gives me 1,176 newtons, and of course gravity pushes down. Now my normal force is pushing up, my force applied is pushing up, my force of gravity is pushing down, so I'm going to switch them all so that they are the same. So right now I will just switch the force of gravity to 1,176 newtons up in the negative direction. Now I want to find the normal force. I know the cow is not going up, the cow is not going down. So that means that Fn plus Fg plus F up must all equal 0. I'm looking for Fn. I've already calculated Fg, and I've already calculated F up. So I have to get Fn by itself. I'm going to do that by subtracting Fg from both sides. So the Fg will cancel out. I'm going to subtract F up from both sides, so both F ups on the left-hand side will cancel out. So that means that Fn is equal to negative Fg subtract F up. Now I can sub my numbers in. And when I run that through my calculator, that gives me 762.7 newtons up. I wind up with only two significant figures, so my answer is the normal force is equal to 760 newtons up. Part B, what is the calf's acceleration? Let's bring that cow back in here. Now, the cow is getting pulled to the east, so we know it's going to be accelerating towards the east, and the acceleration is going to be happening in the horizontal. We already established that all the vectors in the vertical cancel out. When added together, they equal 0. So the only things that are going to play into how fast this cow is accelerating are the vectors applied in the horizontal, and that is force applied in the horizontal and the kinetic force of friction. So F net equals force applied in the horizontal plus force of kinetic friction. So we'll substitute our numbers in. They'll both have to be switched to east because east is winning. And that tells us the net force acting on this calf is 91.4775 newtons east. Now I'm looking for acceleration, so I'll use F net equals mass times acceleration. To get acceleration by itself, divide both sides by mass. Mass will factor out. Acceleration is equal to F net over mass. Again, I will substitute my numbers in. F net is 91.4775 newtons east. The mass is 120 kilograms. That gives me 0.7623 meters per second squared. So my answer is the calf is accelerating at 0.76 meters per second squared east. And that's the end of the lesson as we know it. Work on DN2.